Hello everyone. In this video we're going to be solving an equation with fourth powers. I don't want to call this quartic because it's not going to end up quartic. It is going to be actually a cubic equation. Why? Because the x to the fourth power is going to cancel out. And that brings me to my first method. So for the first method, we're going to do the following. We're just going to expand. We have x to the fourth, and on the right hand side we have x minus 1 to the fourth power. How can I expand that? By using the binomial theorem. It becomes x to the fourth minus 4x cubed plus 6x squared minus 4x plus 1. Remember, in the previous video we talked about the binomial formula for a plus b to the fifth power. This is the formula for a plus b or a minus b to the fourth power. So the signs alternate because b is negative, right? If you consider it to be a plus b. Anyway, so we have the following, and x to the fourth nicely cancels out. So let's go ahead and do that. X to the fourth cancels out. Let's put everything on the left hand side, so everything is positive. 4x cubed minus 6x squared plus 4x minus 1 is equal to 0. Unfortunately, this is not easily factorable, but we can definitely use RRT. What is RRT? Rational root theorem. So if you have a rational root, it should divide, or it should be the factors of -1 divided by 4. So you're kind of taking a constant, divide by the leading coefficient. So you can go through those choices, but I'll show you a different approach because this is a very special equation. All right, so what am I going to do? I'm going to go ahead and multiply both sides by 2. Because multiplying by 2 actually serves a really good purpose here. And that is making the first term a perfect cube. And the second term is going to contain a perfect square. I'm not saying it's a perfect square. It's going to contain a perfect square. So everything is going to be perfect. So here's how it goes. I'd like to write 8x cubed as 2x to the third minus. Now I want to follow the same pattern. So instead of my variable x, I want to use 2x as my variable because I'm going to use substitution. You get that? So if I square 2x, what am I getting? I get 4x squared, but I have 12. So I do need to multiply by 3. You see, that's how you can adjust things. So just play around with this idea. It's really cool. So I do need 8x, but I have 4x, I have 2x. So I got to multiply by 4, and the constant doesn't really matter. Poor constant. Okay, what am I going to do next? 2x needs to be renamed. So let's call it u. That is u. So if 2x is equal to u, what happens? We get a nicer equation. Actually, the reason why it's called a nicer equation is because it's monic. Monic means the leading coefficient is 1. So those equations are actually nicer. So anyways, this is u, and that's u, minus 3u squared plus 4u, this is 4u, minus 2 equals 0. Okay, I can't help it. So now we have the nicer cubic version, but still this needs to be worked out. But guess what? One of the things that I keep saying all the time, right? What is one thing that you should always say? If you're trying to solve a polynomial equation, doesn't matter what degree, always check the sum of coefficients. Why? Because if the sum of coefficients is 0, then 1 is a solution. And that happens to be the case. Look at that. 1 plus 4 is 5. -3 plus -2 is -5. Then the sum is 0. So u equals 1 is a solution, which is really cool because then we're going to end up with a quadratic, right? Let's go ahead and manipulate the coefficients here to make u minus 1 a factor. So like this, u cubed minus u squared minus 2u squared. And then I'm going to continue with plus 2u because notice that these terms will have a common factor of u minus 1. I hope that makes sense. And then plus 2u minus 2 equals 0. So now this will also have u minus 1. And that kind of checks out with the fact that u equals 1 is a solution. Factor out u squared, u minus 1, minus 2u, u minus 1, plus happy birthday to you if it's your birthday, by the way, and 2 times u minus 1. Great. So now u minus 1 can be taken out. U squared minus 2u plus 2 is equal to 0. So now we got it down to a linear times a quadratic, which is nice because quadratics are easiest to solve. We have a quadratic formula. We also have a cubic formula, but come on. Who wants to use the cubic formula for this? Maybe some people do. Who knows? So now we're going to do the following. We're going to go ahead and we already know u equals 1 is a solution. We're going to find the other two solutions by using the quadratic formula. So quadratic formula gives us negative b plus minus the square root of b squared, which is 4, minus 4 times 2. And that is going to be 4 minus 8, which is negative 4. And the square root of negative 4 is just going to be plus minus 2i. So we can write this as 2 plus minus 2i over 2. And that is going to turn into 1 plus minus i. So, oops, we forgot something. Okay, b squared minus 4ac divided by 2a. Actually, that looks good. Okay, fine. We're good. So now we can definitely check that this is going to work, because if you add 1 plus i and 1 minus i from Vieta's formulas, that's going to give you 2. If you multiply, you're going to get 2. Okay, great. So we got the values of the u, but u is not what we're trying to solve for. Remember, we're looking for x, and u is equal to 2x. Okay, so u is equal to 2x, and if it equals 1, then from here x equals 1/2. And if u is equal to 2x and that is equal to 1 plus minus I, then from here x equals 1 plus minus I divided by 2. Actually, those are going to be the solutions, and this brings us to the end of the first method and the beginning of second method. Let's go ahead and talk about the second method real quick, and then I'll show you a nice graph. Second method is actually real cool, because this is basically taking fourth roots of both sides. But remember, when you have even powers, you have to consider absolute value. So it's going to give you two branches or two solutions, either this one or the opposite. If two numbers, the fourth power of two numbers are equal, then they're equal or they're opposites. But this is impossible. Look at that. 0 equals -1. No way. So now we're going to have to go with the second one. That's going to give us this. But then 2x equals 1 gives us x equals 1/2. But wait a minute. Where are the other solutions that are complex? Well, you don't get them solving the equation this way, because this is a very real solution, and it doesn't give you any complex solutions. But don't worry. Once you know that x equals 1/2 is a solution, you can go ahead and turn it into a cubic, but don't use the first method, and divide by x minus 1/2. So x minus 1/2 is going to be one of the factors, and it's easy to find the other factor by long division or whatever division you want to do. Let's go ahead and take a look at the graph real quick, and then we'll wrap it up. Here you go. You have two quartic functions. One of them is actually a shifted version, so kind of transformation. Is that what it's called? So they intersect at 1/2, 1/16, which means x equals 1/2 is the only real solution. Obviously, this doesn't show us the complex solutions, but you can find them by division. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.